My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 473. In this lecture, we will try to understand how to initialize K means. So, in Lloyd's algorithm, for K means has the first step as initialization stage. So, in the previous lecture, we showed that we can do the random initialization where we pick k points randomly from dataset capital D and make these k points as k centroids C1, C2, so on Ck. This is called random initialization. This scheme is called random initialization scheme. Random initialization is very simple idea. K-means has a problem called initialization sensitivity. This is a problem. This is one of the drawback of random initialization. Random initialization sensitivity means that your final clusters and centroids depend on how you pick your random points in initialization stage, which means final results are sensitive or dependent on initialization. We will see some examples with toy data sets. We will see some examples on how to choose different set of random points results in a completely different clusters. But this is the problem of random initialization has. It has initialization sensitivity problem. So let's look at some toy data sets to understand in more detail. This is very nice presentation, very nice lecture slides. Very nice lecture slides, I believe. Cluster and all on cluster analysis topic. I have picked this from web link. Anyway, I will post this web link in reference for this particular lecture to credit actual people who done it by Professor Ala Al-Fuqaha. He heads the research center for applied science and artificial AI specifically at Western Michigan University. I believe these are his lecture slides which I am borrowing for this lecture. I will keep revisiting these specific slides because he covers some of the examples brilliantly from very graphical standpoint. Let's take this example where I have two features, F1, two features. Just ignore X and Y here. Let's call them feature 1, F1, and feature 2, F2. These are two features. These are original data points, isn't it? And all these data points are colored, all these data points are colored in green. All these points in green colored means, let me say that is cluster 1, and all these points are in red color. Let me say this is cluster 2. This become all the points in blue becomes cluster 3. All the points in green becomes cluster 1. All the points in red becomes cluster 2. Isn't it? Yes. Given the data set, this is what I expect algorithm to. Just if I have data set like this, given the data set, this is what I expect algorithm to return. This is my original, let me say this is my original points with human labels, human generated labels. If I give it to human person and ask them to generate clusters, this is what they will generate, isn't it? This is what they will generate. Yes. Given this ideal data set, this data set itself is the ideal data set, isn't it? Now I apply k means with different initializations. I could get, if I apply K means algorithm, I could get this as one outcome, isn't it? This as one outcome. This results, I have all of the points as all of these points as one cluster, isn't it? And if I and these points, there is another cluster, this is another cluster, isn't it? And these points, let me say I have 3 clusters, isn't it? How will it be? This is, if you observe this one, just see, yes, this is very similar to my original data. If I compare them, just compare this and this, they are similar to, this clustering is similar to my original data. All the green points are clustered, all the blue points are clustered, and my brown points are clustered, isn't it? The only difference here is, what is the difference here? This. Just see these points. Here I have these points, these 2 points. What is the difference? The only difference. Yes. The only difference here is these points. Which points? This point. If I compare this point, these 2 points with these 2 points, isn't it? Yes. The only difference here is these points. I can say there is a small difference with the original clusters. There is a small difference with original clusters. That's okay. This is very, very similar to, except for these 2 points, isn't it? Except for these 2 points. But by choosing slightly different initializations, I can get this result. If I choose slightly different initialization, by choosing one initialization, by choosing first initialization, this is one initialization, this is different initialization, isn't it? If I choose one type of initialization, I am getting these clusters. If I choose some different type of initialization, I will get these clusters, isn't it? Let me say like this. Yes. Just let me repeat myself. I can get this diagram 2 by choosing. One initialization. By choosing different initialization, I will get this one, isn't it? By applying same Lloyd's algorithm, on the same data itself, but using slightly different initializations, I can get completely different results. Diagram 3, you are getting completely different results. In this results, what happen if I choose some different initialization? This is for first one type of initialization, this is for different types of initialization. So if I choose some different initialization, in this all these points, what happens if I choose some different initialization? I will get this one. What will I get if I choose this is one initialization, one type of initialization, this is different initialization, isn't it? What happens here? In this rate, all these points become one cluster, these points become, this is second cluster, isn't it? And these points become third cluster. This is C1, this is C2, this is C3, isn't it? Cluster 1, cluster 2, cluster 2. This is very different from what I am expecting you to generate, is it not? It is different. This one is different from what I am expecting you to generate. Just compare this. Just compare these two. Compare these two. You are getting different. Just compare this one and this one. This is not what I wanted. This is not what I wanted, isn't it? This is not what I wanted. This is what this is what I wanted to generate. This is what I wanted to generate, but not this is what I wanted to generate. Isn't it? Means diagram 2 is okay. This is okay. This I want to generate, but not this. Isn't it? How can I say this one? Just let me say like this. Yes, you can get this undesirable. You can say this one is undesirable. I can say this is undesirable results. Which one is undesirable? This one. Undesirable. You can get this undesirable result by just changing the undesirable result by just changing the initialization. This is okay for one initialization. This is for one initialization. This is for different initialization, isn't it? I will show you the example what initialization creates. Which initialization, we will try to understand this, which initialization creates this particular one, and what initialization creates this one, which initialization creates this figure, and which initialization, we will try to understand which initialization creates this one and which initialization creates this one, isn't it? So let's go step by step. So imagine if my initial centroids are this. Just see first figure. These are three initial centroids. Just if you observe carefully, this is one centroid, this is another centroid, this is another centroid. These are the three initial centroids. In the first iteration, what happens in assignment stage? All the points that are closest to the centroid, just what happens, just see. All the points in assignment stage, what happens? All the points that are closest to the centroid, first centroid, all the points, just see like this. All the points which are closest to this particular all the points which are closest to the first centroid get assigned to this particular cluster. Let me say C1, isn't it? All the points that are closest to this centroid are assigned to this cluster, isn't it? Or get assigned, all the points that are closest to this centroids are get assigned to this cluster, isn't it? Yes. To the again there is an update stage where updating the centroid with each iteration. Remember this is iteration 1. This is iteration 1, iteration 2, iteration 3, iteration 4, iteration 5, iteration 6. Isn't it? How many iterations are there? There are 6 iterations. With each iteration, my centroid change. The location of my centroid change. Eventually, I will reach a stage at iteration 6. Just say at iteration 6, where the centroids from the iteration 5 has not changed much. Just if you compare iteration 5 and iteration 6, my centroids has not changed much. Since my centroid location has not changed, my centroids did not change, and hence I terminate my loop here. My final clusters are, this is my first cluster. Which one is my first cluster? Just if you observe, this is my first cluster, this is my second cluster, this is my third cluster, isn't it? Having these 3 points, just see this one, this one, this one. Having these 3 points as my first 3 centroids. These are this one. Yes, having these 3 points as my first 3 centroids. This one. Isn't it? I got desirable result. This is desirable result, isn't it? Good results that I am expecting. Now let's see what happens if my cluster centroids are chosen slightly different. Imagine if my first centroid were picked here. Where is my first centroid? let me say this is my first centroid, my second centroid, this is my second centroid, this is my third centroid, isn't it? Because remember, in my random initialization, each point has the same chance of being picked as a random initial centroid. Now what happens is, eventually look at iteration 1, just see iteration 1, iteration 2, keep updating. I will go through my assignment and update iteratively by the time I reach iteration 5. If you notice, my centroids have not moved much. Centroids at iteration 4 centroid and iteration 5 centroids have not changed. This is iteration 4, iteration have not changed. But if you look at final cluster, I got this as if you look at final cluster, what is my, this is cluster 1, this is cluster 1, cluster 2, cluster 3. Cluster 1, this is cluster 1, cluster 2, and this is cluster 2, which is completely undesirable. This is not I expected to return. So by just having different initialization, anyway, this initialization generated undesirable results. The previous initialization, like what is this previous initialization? This is my previous initialization. Just recall. This is my previous initialization. The previous initialization, like this previous initialization, like this, generated what we want. So the big problem in the whole of K means, one of the big problem, I should say, is initialization sensitivity, which means by just changing my initial points, we will get completely different results, like this, isn't it? This is very nice example. Now the question here is, how do you deal with this problem? There are two ways to deal with this problem. The first way to deal with this problem is to say, I will repeat my K means multiple times with different initializations, and I will pick the best clustering based on lower intra-cluster or smaller intra-cluster and larger inter-cluster distances. So what I will do here, I will repeat K means multiple times with the various initializations, and I will pick the best one either by visual inspection or by looking at intra-cluster and inter-cluster distances. This is one way. Of course, you have to repeat it multiple times. The second way, very interesting. The second way is called K means plus plus. The name become the name because C is very popular programming language. C++ is updated version of C. Similarly, K means is updated, or K means plus plus is the updated version of K means. So K means basically says that in K means plus plus. K means plus plus basically says that instead of using random initialization, it replaces random initialization with a smart initialization, scheme, except that the whole algorithm is exactly same as the K means. The only difference between K means and K means plus plus is the initialization part. Just go through this lecture. I will continue how to initialize K means in my next lecture also, that is in lecture number 474. Thank you very much.